in this paragraph, in this unit, in this paragraph, actually, 4b, bless you, we're going to be looking at some terms. So variable, expression, equation, terms, blah, blah, blah. All of these things, we'll see what they mean today. Now, variable, what is a variable? Let me show you. Basically, a variable is a letter. So usually we use these letters here, like this L and this W, to represent something which could take various values. That's why we call it variable. You see, inside the word variable, we've got the term vary. So vary, the verb vary, means to take multiple values. So you could take any value. Okay, now moving on to, so basically this L and this W here would be variables, and P also. All of these letters here, P, L, and W are variables. Now let's move on to another term we're going to be looking at, which is expression. So I'm going to zoom back in to show you some expressions. So here you see we've got letters, numbers, all of them mixed up together with pluses and minuses. This whole thing here is an expression. Then here, the same idea, we've got some letters being added, divided by another letter. So basically what we have here is another expression. So expressions are basically, let's put it like this, variables with pluses and minuses and times and division all grouped together. So we say this is an expression, this is another expression. Expression. Yes, so these are called expressions. Then moving on to another notion, which is the notion of equation. So here we have, basically, if you look at it, we have an expression on the left, number on the right. The most important bit here, though, is this equal. So when you have expressions with variables, like this x here, it's all mixed up together, and it has an equal as well, then this equal makes it into an equation. So equations are basically algebraic expressions mixed in together with an equal, and there is something that we don't know. So there's some kind of variable there. You see this x, this is a variable. So because of this variable, which we don't know what it is, right, this becomes an equation. And often you'll see in the future, we'll be solving these equations. We'll be trying to find what x is. And then same idea here on the right, you see we've got an equal here. So because of that equal, we've got an equation. So this whole thing with the equal and the both sides, the left-hand side and the right-hand side, will be called an equation. Okay, moving on, a few more to talk about. One will be term. So what is a term? So let's move on to this expression here. So you see this whole thing we mentioned before, something like this would be called an expression. But inside the expression, we've got little building blocks. So basically, you see how we've got this 3x, this minus 2y, this plus xy, and this minus 7. Well, all of these are called terms. So this is a term, this is another term, this is another term, and this is another term. So these fellas here, they're called terms. So this expression has 4 terms. 1, 2, 3, 4. And let's look at another one. Do we have another one here? Nope, that's it. So for now, let's just look at this expression. It has 4 terms. Now, moving on, tiny bit more to go. Bear with me. We've got to talk about like terms. So like terms are terms which kind of have the same letters, if you like. So here, if you look at this entire expression here, bless you, it has 4 terms. We have 4x, 3y, xy, and minus 3x. So which ones of these have exactly the same letter? Yes. Yes, so that would be the 4x and the... Exactly, but we tend to take that with the minus, so it would be the 4x and the minus 3x. So notice these two have the same letter, so they are like terms. So the only like terms here are this 4x and minus 3x. So they are like terms. So let me put a smiley face here because we like terms. Now the other ones, yes.
XY and 3y like terms.
Very good question. Because how do we separate it? We look at the letters after the number. So you see here, the letter, the variable is y. Whereas in the other one, the letter or variable is actually xy. So effectively, when there's an extra letter, it counts as a completely different thing. Because we can't just say, I'm going to spot that y and, oh, therefore these two are the same, because they're fundamentally different. We will see some other ideas like collecting like terms later. And last lesson, maybe you saw this a little bit. You can do something with this 4x and the minus 3x. Just put it on silent, guys. It's fine. Put it on silent. Feel free. This 4x and the minus 3x, we can actually count. Yes, it's in the box, probably. Yeah. No worries, guys. So if you have 4x and minus 3x, ignore the telephone. Please do not embarrass him. It's fine. He didn't do it on purpose. All right. So we have 4x and minus 3x. You see, we can actually combine these. So we can say, I've got 4x and I'm going to take away the 3x. So how many x do I have left? 1x. So this happens with like terms. The other ones, though, are unlike. We can't do, 3y plus xy. You know, we can't really combine them because they're fundamentally different. So this is kind of the idea. So basically, we call them unlike terms. So the other ones are unlike terms. So let's put a boo sad face there. We don't like you. You're unlike terms. All right, moving on to two more. One of them I really like personally. It's called the constant term. Guess why I like it? Yes, it's almost my name. It was almost called Constantine, but then somebody said, no, that's my name. You're going to be called Constant. That's it. All right. So basically, out of this expression, there is one thing that stands out, and that is this 7, because it's the only one that we always know what it is. 3x, I don't know what it is. Minus y squared, who knows what that is? Plus x cubed, no one knows what these are because they're letters. They can take any value. But this 7, boom, it's always going to be 7. So 7, we call it a constant term. And I like it because it has a name like mine. All right, moving on to the last one then. Last one, coefficient. Coefficient. A strange word, one that we almost never use except in maths and some sciences. So the coefficient is simply the number in front of a letter. So you see this 4. The 4 is the coefficient of x. So it's the number in front of x. Simple as that. Now this 2, the 2 is the coefficient of, what is the letter that comes after that, or the letters that come after that? xy. So that's the coefficient of xy. And then finally, this would be quite hard to see if you couldn't see this invisible minus 1, which is in front of y cubed. So when there is no number there, it's implied that the invisible one is there, always lurking, hidden in the shadows. So that minus 1 now is actually the coefficient of y cubed. So this one is perhaps a little bit more tricky. Minus 1 is actually invisible. So let me put that there. All right. Yes.
So when there's no number, there's no coefficient?
Well, actually, when you have something like x, then this means 1x. So the coefficient is 1. So when there's no number, the coefficient is actually 1. It's the hidden one, the invisible one. And if I had something like minus w, then this is actually minus 1w. So this means the coefficient of this one is minus 1. So let's keep these tricks in mind. Yes.
Like how would I know if it's not 4x plus 2xy minus y to the power of 3, or if it is minus 1 y to the power of 10?
So you're saying you're asking me how do I know if the 1 is cubed, or how do I know if the y?
How do you know if there's a 1 or if there's not?
When there is a letter and it looks like it's got nothing in front of it, there is always an invisible 1 there.
It's always 1.
Always 1. Yes. 1 is the only number that has an invisibility cloak. Basically, it puts on the invisibility cloak and disappears. Yeah. If you don't have the minus, if you have a minus, it's actually a minus 1 because the 1 is always there hiding. If you don't have a minus, it's just 1, positive 1. So if there's a minus, the minus is not hiding. It always reveals itself to you. Yes. It's always 1x. When it's x, it's 1x. But no one says 1x. It's just x. We just say x. We simplify it, and it's always 1, but we don't write it in a way. Okay. Now, I think it will make more sense as soon as we look at an example as well. Let's have a look at this example very quickly. Is this an equation or an expression? Why is it an expression? Exactly. Well done, guys. So it's an expression because it doesn't have an equal. If it had an equal, exactly. So it's an expression because it doesn't have an equal sign. Equal sign. Okay, brilliant. How many terms does it contain? Let's count. 1, 2, 3, 4, 5. So we have 5 terms. So remember, terms are the little building blocks of an expression. How many different little things we have? Okay, now we are starting to get to the juicy part, the coefficient of x. Well, hold on a second. Where is x? So not the x squared, the x, the alone, the x which is alone. So hands up if you think it's 6.
What?
Hands up if you think it's something else.
What?
Hands up if you didn't put your hand up at all. Okay, so great. Basically, you're very, very close. Unfortunately, it's not 6, it's -6. So the minus plays a role. So it's actually -6. All right, so the number in front of x is -6. All right, moving on to the other one. Yes, let's have a look at the next one, which is x squared. Yes, feel free to call it out, x squared. So here we're talking about x squared, right? X squared, x with a little square. Yes, so we want to go and find that letter. No worries, we find it, and now we're saying it, and some other people called it out, that here, if you look very carefully, let me just zoom in. Let me see. If you zoom in quite a bit, you will eventually see it. It's there, you see? Yeah, so if you zoom in quite a bit, you can see it. Sometimes you can't see it from a distance. So that number there is the invisible one, the coefficient of x squared. Right? So coefficient. Do we have a question there, guys? Can I help? Yes? Do you have a question on this? Okay, let's do the last one together. Let's do it. Finally, the constant term, Mr. Constantine's cousin. Very close.
Oh, -5.
-5. -5. So, pay attention here, guys. We've got an important announcement to make. This is the constant term, -5. This is the constant term. How do we know it's the constant term?
Because it has no letters.
Exactly. No letters, no variables. So that would be the constant term. And this concludes the theory. This is really what we're doing today, the theoretical part of today's work. All right, I'll stop this recording here.